Hi guys, before you judge the quality of my video based on the number of views or subscribers I have, I want to say that I just started my YouTube channel. I am Asif Ali from a physics background and I just got the offer letter for PhD from IISc Bangalore. I have cracked interviews from IITs and IISERs and at last I got the most desired one of any researcher, IISc Bangalore. During the process of preparation for such interviews, I gathered a lot of questions from those who have actually cracked such interviews and are doing PhD now in these institutions. I would say this is the only playlist you would need if you are going to attend an interview for condensed matter physics field. Even if you are going to attend interviews for other areas of physics, I would suggest you to look at the last video in this playlist where I have discussed how to behave in the interview hall. What is the attitude you should maintain while trying to answer the questions? I know that you are trying to prepare for PhD interview for getting into IITs, IISERs, IISc or any other major research institutes. I know your biggest concern. It is what to study, right? Because you have 1 week or 2 weeks or 3 weeks to prepare, but don't have a syllabus and don't know what to study. Don't worry, I am here to give you a proper plan. The first thing you have to know is that if you are going to attend interview for condensed matter physics, then 2 subjects, that is solid-state physics and mathematical physics, are mandatory. You can't ignore that. And it is wise to choose quantum mechanics as the third preferred subject, so these 3 topics are enough. So to start with, the first step is that you have to revise the topics. Take your MSc notes or the textbooks that you referred and revise only the topics that I am going to mention in the video for solid-state physics, or you can download the PDF that I have attached and also refer it from there. For mathematical physics, follow the instructions that I am going to give you in this video to learn the graph plotting techniques and the possible functions that would be asked in the interview. For quantum mechanics also, revise only the topics that I suggest you from your MSc notes or the textbooks you referred. I will also share a PDF for quantum mechanics as well. The second step is the most important one. It is the questions. Go through all the questions that I have discussed in the videos of this playlist. These are the questions that have been actually asked in the PhD interviews in various IITs, IISERs and IISc. It is highly probable for these questions to get repeated in your interviews, or at least the concept you will gain will help you to answer the questions that will be asked in your interviews. The third step is to know what is the attitude you should maintain while in the interview hall, to know what they expect from you. I have explained this with an example on the last video of this playlist. The fourth step is networking. For instance, if you are going to attend an interview for physics department of IIT Bombay, go to the website of that department and go to the people section or student section and note down the name of all the PhD scholars working in that department, preferably those who are working in the condensed matter physics field. Now go to LinkedIn, search their names and connect with them. To easily get their profiles, type the institution's name along with their name. For example, if you are searching a PhD scholar from IISc named Ramesh, search Ramesh IISc. After connecting with them, message them this sentence: I am going to attend a PhD interview in your department, so it would be so nice of you if you could share your interview experience. I guarantee you that if you message 5 PhD students, at least 3 of them will respond and will give you their phone number for you to contact them. Now call them. You will get to know about the nature of the questions that would be asked in the department. Maintaining these contacts will also help you even for choosing the suitable advisors as well. I personally contacted 4 of the PhD scholars from IISc and it helped me a lot to crack the PhD interview of IISc. So that's it. If you follow these 4 steps along with me, I can guarantee you that the probability for you to get selected increases considerably. This is my mail ID and phone number. You can contact me if you have any queries. Before starting the first step of the plan, I want to tell you that I have put a lot of efforts to make these videos for you. So it is my sincere request to you to subscribe my channel and put a like if you find the content valuable. So let's start the first step. Coming to the first section, let's see the important PhD interview topics. Let's start with solid-state physics. If you're going to attend a PhD interview in condensed matter physics, theoretical or experimental field, solid-state physics is mandatory. So the first 2 topics are obvious, Jude's model and Sommerfeld model, and the comparison between these 2 models. So just learn the postulates, merits and demerits of these 2 models. Don't just dig deep into these models. derivations are not needed. Just see the postulates, merits and demerits of these two models. And it is very important to study the comparison between these two models. So in an interview, it is more probable to ask what are the differences between these models? What are the advantages of this Sommerfeld model over the Drude's model, like that? And one more thing to say is that Drude's model is also known by the name classical free electron theory, and Sommerfeld model is also known by the name quantum free electron theory. So during interview, they can ask either of these names. They can use either of these two names. So don't get confused. And the fourth topic is Hall effect. It is very important. Many of my friends who have attended PhD interviews in IITs and IISERs, they have came across questions from Hall effect. They can ask you to derive Hall voltage, Hall coefficient by drawing a diagram. So be prepared for that. And the fifth topic is tonic penny model. It is very important because it is more accurate description. It gives more accurate description of how electron moves in a solid when compared to these two models. So you have to see the derivation also for this topic, because only when you see how it is derived, how the last equation is derived from by applying the Schrodinger equation, boundary conditions and all, only then you will get the concepts which will help you to answer the questions that will be asked during the interview. So look into it. I'm just saying the important topics here. I'm just giving you a roadmap. So you will get a plan from this. So if you are having 1 week or 2 weeks for your interview, you can easily study all these topics. Even 5 days are enough for these things. The sixth topic is band theory. It is very important because I'm very sure that at least one question will be asked to you from this section. So I have attached a link in my description box from which you can watch some NPTEL lectures. So kindly watch it. It is very important. Different types of questions can come from this band theory. I will include some of the important questions that I have faced from this part in the next section. Kindly see that. And the seventh one is specifically capacity of solids and the three theories associated with that: Coulomb-Petit law, Einstein's theory, Debye's theory. So just see what are those theories and give importance to the differences, the advantage of one or the other. In any law theory, they will not ask you directly what is the definition of that law or theory. They will ask you the differences between those two theories, those two different laws, like that, advantages of one over the other. So give importance to the differences, advantages, disadvantages, like that. So in Debye's theory, that T-cube dependence of specific heat is derived. So kindly give importance to that also. That is very important in this part. And also see semiconductors. Just know the basic steps of semiconductors. What are N-type semiconductors, P-type semiconductors, how the p-n junction is formed, and also learn the EK diagram of direct bandgap and indirect bandgap semiconductors. These concepts are beautifully explained in the link that I have provided you. So watch the videos that I have provided you. It is very important. And the ninth topic is superconductors. Now the basic stuffs of superconductors like perfect diamagnetism, Masonry effect, and address these two questions. The first one is how BSC's theory explains the formation of Cooper pair in superconductors. Even though electrons have same negative charge, they are forming Cooper pairs. So how it is happening? So learn how to explain on the basis of BC's theory. And the second question is how BC's theory explains the origin of superconductivity. So I will address some of these questions in the next section. And the 10th one is magnetism. Know the different types of magnetism that exist in the material, like ferromagnetism, ferrimagnetism, antiferromagnetism, paramagnetism. Know the domain structure, know how the spins are aligned in these magnetic materials. Also seeing the graphs like magnetization versus temperature graph for all these type of magnetic materials, and susceptibility versus temperature graph for all these magnetic materials. So these are the important questions that can come here. I will include some important questions that can come from here also. Apart from this, you also need to look into lattice vibration, the monatomic case, diatomic case. You should know how to draw the dispersion relation graph for monatomic as well as diatomic case, the long wavelength limit, the short wavelength limit. You also need to know how to plot the B by A ratio for this diatomic case. For this also, you can go through the PDF that I have provided. All the important points are mentioned in that PDF. Lennard-Jones potential is also needed. So kindly look into that also. Let's come to the mathematical physics part. Here you have to see the graph plotting. You have to learn how to plot the combinations of all these functions like x and e raised to x. You have to see how to plot x into e raised to x by e raised to x, e raised to x by x. Similarly for modulus of x and e raised to x, modulus of x into e raised to x, x modulus of x by e raised to x, e raised to x by modulus of x. Similarly, learn how to plot all these combinations. You can use this app called GeoGebra. GeoGebra. It is available in Play Store, so you can install it there, or you can directly go to Google and type GeoGebra, and you can type the given functions, and you can check whether the graph you plotted is correct or not. I will give one example for you to know how to plot this function step by step. You can use this method to plot any function. Let's see one example. Y is equal to x into e raised to x. So first step you have to do is write the individual parts of these functions. For example, here it is y is equal to x and y is equal to e raised to x. This is symbol a straight line which passes through origin. And here it is symbol exponential function. So this is the first step you have to do. Second step that you have to do is, the second step is that just analyze the graph. Like at x is equal to 0, when x is equal to 0, y is equal to 0. So that is one thing. And second thing is differentiate the given graph. Y dash is equal to y dash is equal to x into e raised to x plus e raised to x. So see where the first derivative becomes 0. Let's put it equal to 0. And we can see that x into e raised to x is equal to minus e raised to x. So x is equal to minus 1. At x is equal to minus 1, the derivative is 0, which means that at x is equal to minus 1, either a minima or maxima can exist. So from these informations, you can see that you can generally draw it like I am redrawing the individual functions. Y is equal to x look like this, and y is equal to e raised to x. It looks like this. And we know that at x is equal to 0, the resultant function is 0. That is, y is equal to x into e raised to x is 0 at x is equal to 0. And we also know that there will be a maxima or minima at x is equal to minus 1. And now we have to see what happens to the function at x is equal to plus infinity and x is equal to minus infinity. For x is equal to or x tends to plus infinity, the function y is equal to x into e raised to x tends to infinity. And for x tends to minus infinity, y is equal to x into e raised to x. We can write this function as y is equal to x by e raised to minus x. So that the form becomes, when x tends to minus infinity, this form becomes infinity by infinity. So we can use L'Hopital rules, L'Hopital rule. So we can use L'Hopital's rule. So we limit x by e raised to minus x when x tends to minus infinity is equal to simply differentiate the numerator and denominator. Limit x tends to minus infinity 1 by minus e raised to minus x. So when we put minus infinity here, we will get 1 by minus infinity, which means 0. So we got that when x tends to plus infinity, the function y tends to infinity. And when x tends to minus infinity, the function y is equal to 0. What we can conclude is that the graph looks like this. So at x is equal to 0, the function is 0. And what we also know that when x tends to infinity, the function tends to infinity, like this. And when x tends to minus infinity, the function tends to 0. And there is a maxima or minima at x is equal to minus 1. So the function is coming like this. So we can easily understand that the graph will be like this. There will be a minima at x is equal to minus 1. If you are not sure whether it is a maxima or minima, you can simply differentiate it again. You can simply differentiate the function x into e raised to x again and check whether if it is negative or positive. If it is coming to be positive, then it will be a minima. If it is negative, then it will be a maxima. Let's see another function. Y is equal to sine x by x. So as I have already said, decompose this function. Plot the individual parts of that function. For example, here it is sine x. It looks like this. The second part is 1 by x. By x looks like this. So first part is done. Second part is analyze the function. At x is equal to 0, what happens? We know that at x is equal to 0, sine x is 0, but here it is infinity. So we cannot simply write the function y to be 0 here, because y is equal to sine x by x. So when we put x is equal to 0, it will be of the form 0 by 0. So we have to use L'Hopital's rule. So when we apply L'Hopital's rule, we just have to differentiate numerator and denominator. So when we differentiate it, cos x by 1. So when we put x is equal to 0 here, we will get 1. So now we know that at x is equal to 0, the y is equal to 1. Now let us differentiate the function y dash is equal to derivative sine x, that is cos x, into x minus sine x divided by x square. So we have to see where it is equal to 0. Equating it equal to 0, equating to 0, we get that cos x into x is equal to sine x. Then x is equal to tan x. So from this, we can understand that y dash, that is slope, is equal to 0. First derivative is equal to 0 at multiple points of x. At all x, where x is equal to tan x, y dash is equal to 0. So there will be many maxima and minima occurring at x, where x is equal to tan x. For x is equal to 0, from this equation we can see that at x is equal to 0, we know that tan 0 is 0. So x is equal to 0 satisfies this equation. So at x is equal to 0, a maxima or minima can occur. Now going to the third step. When x tends to infinity, x tends to plus infinity, y is equal to, we know that y is equal to sine x by x. We know that sine x, the value of sine x will vary between -1 and +1, whatever be the value of x, independent of the value of x. So even when x tends to infinity, the value of sine x will be between -1 and +1. So any finite value divided by infinity will give us 0. So y tends to 0. Similarly, when x tends to minus infinity, also applying a similar logic, we get that y tends to 0. So concluding all the points, our final graph will look like we know that at x is equal to 0, the function of y, the function's value is 1. And we also know that we will get a maxima or minima at multiple values of x. And when x tends to infinity, y is tending to 0, and x tends to minus infinity, y is tending to 0. So, but here, as at multiple values, there are maxima and minima. So here we have to analyze it more for getting the final curve. So it may arise, even though you do these 3 steps, you will not get the curve of the function at the end. So you have to apply some more analysis. Like here, we can see where the value of the function is becoming 0. So y is equal to sine x by x. Y is equal to 0 when sine x is equal to 0. So we know that sine x is 0 when x is equal to n pi. So at all these points, the value of the function becomes 0. For example, pi, 2 pi, minus pi, minus 2 pi. So at these points, the value of the function becomes 0. Now we have to apply some logic. Draw the individual graphs. I'm redrawing the individual graphs here. We know that sine x is like this. At this part, it is confirmed that value of y is 1 and the function's value is becoming 0 here. So like this. But as we move away from the origin, what happens to the value of sine x is that we are multiplying sine x by 1 by x, right? So when x moves away from origin, the value of 1 by x is becoming more and more nearer to 0. What happens to the curve sine x is that the value, the range becomes narrower. The value of y becomes more and more nearer to 0 as x moves away from the origin. Like this. The value of y becomes more and more nearer to 0. So this is how the final curve will look like. So simply what you have to do is whenever you get a function, draw the individual parts of that function. Like here sine x by x, draw 1 by x and draw sine x like that. And the second step is put x is equal to 0 and find the value of y. And there you have to apply L'Hopital's rule if it is required. And also in the second step, we have to find derivative and find where the maxima and minima occurs. If you are not sure whether it is some maxima or minima, you can find the double derivative as well and see if it is positive or negative, and depending on that you can find whether it is maxima or minima, but it is not required in most of the cases. And in the third step, you have to see what happens to the value of the function when x tends to plus infinity and when x tends to minus infinity. And so these are the points you should keep in mind. And depending on the function, you have to do some additional analysis. Like here in this case, we have to see where the function is becoming 0. So we'll get an overall idea of the curve. And sometimes you have to apply logic like this. This is sine x, 1 by x. At x is equal to 0, we have already found out the value of y1. And we know where and all the function's value is becoming 0. And from here, we can see that when x moves away from the origin, sine x into 1 by x, right? So 1 by x is becoming more and more nearer to 0. So anything which gets multiplied by 0, it becomes 0. So whenever a number is multiplied by smaller numbers, fractions, it becomes less, right? So as sine x is multiplied by 1 by x, with 1 by x becoming more and more nearer to 0, the product sine x and 1 by x, the product of sine x and 1 by x becomes more and more nearer to 0 as x moves away from the origin. So from all these points in mind, you can draw this picture. And one more thing I need to tell you is that whenever you are given a particular function, you have to tell them all these points, even if you know the final curve. For example, if they give you the function sin x by x to plot, you know already how it looks like. So don't just draw this is the curve, this is how the curve looks like. You have to include all these points. Tell them what you're thinking. Like, first of all, draw the individual parts and say to them at x is equal to 0, the value of the function becomes like this, and at the derivative, find the derivative, equate it to 0, and say to them at these x points, the derivative is becoming 0, the slope is becoming 0, so maxima or minima can occur. And third point, at x is equal to plus infinity and x is equal to minus infinity, the y is becoming like this. So from all these points, remembering all these points, we can draw like this. So you have to tell all these processes to them. They are checking whether you have got concepts to think how the curve will look like at the end. So don't just draw the final curve. Then they will think that you have mugged up the curve. The third example I want to tell you is sine 1 by x. So this is a special function. You cannot follow the steps that I have told you before to evaluate the function. Here, what you can only say when they ask you to plot this function is that it is an oscillating function. And when x tends to plus or minus infinity, 1 by x tends to 0. So sine 1 by x tends to sine 0, which is equal to 0. So you can say like that. And you can add that as x becomes more and more closer to 0, the function oscillates or fluctuates faster until at 0 it is oscillating or fluctuating infinitely fast. So it has no limit. So it looks like this. You can plot this function in GeoGebra and you can get a good picture of this. These are the things I want you to remember while plotting. If the function given to you is even function, it should be symmetric with respect to y-axis. So these points you can use to check whether the function you have plotted is correct or not. If for example, if it is sin x by x, sin x is odd by odd is even, odd into odd is also even, odd by odd is also even. So it should be like this. If it is like this in the positive x-axis, it should be like in the negative x-axis. If it is an odd function, it should be inverted with respect to y-axis. For example, consider the case of x cos x. Individual functions like x looks like this and cos x looks like this. You can follow the steps that I have told you before to draw the final graph, or you can simply apply logic. Here, x into cos x will be 0 when x is equal to 0. At x is equal to 0, the function will be 0 because at x is equal to 0, right? So, and then as x moves away from the origin, cos x is an oscillating function, but the value of x is becoming more and more large. So what happens is that cos x continues its oscillation, but the value of x becomes more and more large. So the product x into cos x becomes more and more large, but still oscillating like this. As it is an odd function, you have to invert it. You should not draw like this. You should not draw like this. You should draw like this. Like this, it should come like this. Inverted way. Third point I want to tell you is that be careful about the function log x. We know that log x is only defined for positive value of x. So whatever be the combination in which log x is included, the overall function should always be defined on the positive x-axis. Because in the negative x side, log x is 0. So anything multiplied by 0 will become 0, right? So the overall function will be defined on the positive x-axis only. But it is not the case when it is log modulus of x, log mod x. Then the function log modulus of x looks like this. Then x into log modulus of x is odd, log modulus of x is even. So odd into even is odd. So you have to draw similar to this, like at the positive x-axis, the function looks similar to x log x, but at the negative side, the function looks like as the resultant function is an odd function. Odd into even is equal to odd, just invert it. Like this. I want you to look into this combination as well, combinations of x and log modulus of x. And another important topic is probability. See what are permutations and combinations, which is applied in what type of problems. You should know how to distinguish between these two. Only see the basic questions, simple questions. They will not ask too deep, difficult questions. Then these are some topics that is usually asked in the interviews. Binomial distribution, do some problems related to binomial distribution, basic questions. And second one is a typical question asked in the interview. How to prove arithmetic mean is greater than or equal to geometric mean? So this can be done like this. So to prove that arithmetic mean is in general greater than or equal to geometric mean, you can use this method. You can use any method. I have used a simple method. Arithmetic mean of two numbers, x1 and x2, where x1 and x2 are greater than 0, greater than or equal to 0. Then arithmetic mean is given by x1 plus x2 by 2. Geometric mean is equal to square root of x1 into x2. And just take the square of x1 minus square root of x2. Square root of x1 minus square root of x2 whole square is given by x1 plus x2 minus 2 into square root of x1 into square root of x2. Then divide the whole equation by 2. Then we'll get like this. This x1 plus x2 by 2, we can write it like arithmetic mean. And square root of x1 into x2, we can write it as geometric mean. Then we know that the left-hand side is a positive number, as it is a square. It should be greater than or equal to 0. Then it means that arithmetic mean is in general greater than or equal to geometric mean. You can use this simple method to prove that. And here, third one is see how to find the nth term and sum of n terms of arithmetic as well as geometric series. And you know arithmetic mean and geometric mean, but there is another mean. There is one more mean, harmonic mean. A question from harmonic mean was asked to me in IISC interview. So I will share it to you in the next section.